everyone. Welcome to today's Noveg webinar, Hybrid 3D Reverse Engineering with QUICKSURFACE 2024. QUICKSURFACE is already recognized as one of the easiest and fastest software for reverse engineering of scan data from any 3D scanner. The new QUICKSURFACE 2024 introduced simple and effective workflow to make reverse engineering of complex objects even more simple. QUICKSURFACE is efficient, user-friendly, affordably priced, and has a really high precision. It can be used for both small and large-scale projects. Stick with us and find out. Today with us, presenting this webinar is Kostadin Vrantzaliev, who is the product manager of QUICKSURFACE and has been with the team since the beginning, 2010. He specializes in 3D scan processing, 3D scans algorithms, and product design. He also was a key member of the team who built the first handheld 3D laser scanner, fun fact. And let me tell you a little bit about Noveg. Noveg is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, and faster service. Check us out at noveg.com, where you can find QUICKSURFACE and also the entire line of products for mesh to surface. Now, without further ado, I'm going to switch it over to Kostadin. And looking forward to take a look at the new QUICKSURFACE. Take it away, Kostadin.
Thank you, Barbara. And you see the screen. I hope everything is okay. And hello, everyone, and thank you for joining this webinar, where I'm excited to present what we have done in the last year. Because some of you may join this for the first time, I'd like to introduce ourselves and just speak a little bit about our products. Like Barbara said, our company is experienced for more than 26 years. We created the first handheld scanner. That's an old picture, as you see on the screen, back in 1996. We have a lot of experience in processing scan data, and this scanner, as you see now, is known as Nikon Model Maker. We participated actively to handle a large number of points, working on accuracy. But our passion today is more about reverse engineering. Why we speak about this, why we created these products? Well, the message is because 3D scanning is the beginning. You can scan a lot of stuff, but then there is not much you can do with the actual scan data. You need to use them somehow for different purposes. Many people think that actually reverse engineering is simple stuff. As they see the object scanned on the screen, they think it's ready for as an IGS, or you can put it in production, but the reality is not true. It needs effort. You need to spend time to convert this in a proper CAD model, and this is our goal, to provide correct and good tools for doing this in a timely manner. We provide the core features so you can do this with the maximum speed and in a very simple way. But when do we need reverse engineering? We just analyze the areas, and we want to make this clear for everyone to understand. A lot of people joined this industry recently, and they just speak about reverse engineering covering everything, but for us, it's a bit different. What we try to represent on this screen is the different applications that we see. Perhaps there might be more, but this is the major ones. First one is what we call it scan to 3D print. You just scan an object, you probably scale the mesh, and then you send it to a printer. You don't need any CAD model or anything. You just can process this mesh in a free software like Mesh Mixer, make it watertight, and just send it to the printer. The next one is scan to visualization. This is not something that we understand as a reverse engineering. The other big, huge area is for inspection or quality control, and this is where the scan data can be used, but this is also not a reverse engineering. And the fourth one we understand is if you need to replicate parts that they don't have any designs, they don't have any sketches and need to be put back to manufacturing. So the areas where you can use our products is actually in the first one and the last one for manufacturing. Why I'm pointing out scan to 3D print. Even if you scan a part, you just replicate how wrong it is. Because as you see in the picture, it might be deformed, it may be damaged. And if you just scan it and send it to a printer, you actually replicate the same problem that the part already has. So that's why you need to use some tools to improve, change the design, make it much stronger, and then you send it to the printer. And the last one is for manufacturing, which is the obvious approach. Here is why we need reverse engineering. Well, that's another example where you can see on the screen there is a piece that it's missing. Actually, again, if you just take this and send it to a printer, you'll not complete your job. So what you need to do is reconstruct and create the geometries in the right way. So speaking of all this, where we position our product, our major product is called QUICKSURFACE. It's actually this bridge which creates a CAD model from a scan data. We work with any scanner manufacturer that can generate an STL mesh. And once you get this data, you can bring it into our software, and then it outputs the proper CAD model in the industry standard IGES or step file format, which can be loaded in a lot of quite popular packages that you probably use. But because it's an industry standard, every package actually uses IGES or step file format. So what is QUICKSURFACE? QUICKSURFACE is a standalone application which has a lot of simple tools that helps you to start with the imported STL mesh, and then you end up with a CAD model. What do we offer? What type of features? What do we have? Well, as you can see, we listed here. Probably it's hard to read, but just to summarize, we offer parametric modeling, automatic surfacing, freeform modeling. We have our own proprietary approaches to solve different problems that you will see in my technical demonstration. We also offer tools to realign the object in space and more. These are just a few examples of what type of objects we can handle. We don't claim we can do any object in the world, but these are type of object that we can work on. The first one on the top left is a purely prismatic shapes where you can create sketches, you can extrude, combine, and using Boolean operations, you can end up with a solid in a parametric way. Also with our tools, you can do a purely freeform shapes like this helmet. A lot of people are asking that they need to convert pure organic shapes just for use in other applications. And in the bottom row, which is quite interesting, is the mechanical type of shapes where you have a lot of lofts, a freeform surfacing. It's a combination. It's not only prismatic shapes, but quite interesting, which is the topic today, is the hybrid type of modeling. I'm going in details, but you can see in the images how complex shapes you can recreate. We always try to educate people not to have a false expectations of the magics. You know, I dream to have a button where you can press and then everything goes the way you think it is. But we need to be realistic. So what we have in our technologies is what is called automatic surfacing, which is really useful when you don't need a high precision. You just need quickly to convert the scan data into a CAD model, but you don't have enough time to spend. Rough surfaces is good enough for your applications like collision detection, or you want to visualize something, and so on. The other one is the manual surfacing, where you actually need to make everything precise. You need to keep patterns, you need to have a mirror functionality. Why? Because there might be a need to change your design, so you can go back to your parametric modeling history tree and you can change the things. And the last one is called hybrid modeling. This means that you can create objects in a combined way, which means that some of the areas are really important to be precisely created, while the rest, like if it's a casting, for example, you don't really need to have such a huge accuracy. So I hope this introduction was good enough, and I will just jump now directly to our technical demonstration to show you what actually QUICKSURFACE can do with the real data. The new QUICKSURFACE, actually QUICKSURFACE has been on the market for already 5 years now. We released the new 2024, where we added even more functionalities and improve our workflow. For the ones who are just new in our software, it's a standalone application which works on the Windows. You can get a workflow on the main toolbar, which we do our best to align it to the way the workflow it is. So we provide also a lot of scan data processing tools where you can combine the scan data, you can improve for the purposes of reverse engineering. Then you can also do some freeforming, surfacing, and use the standard CAD operation. Also, we provide a lot of analysis tools so you can keep control over the whole process. And at the end, you can just go and export your final result for what you need. I will just start with an object which is very simple. It's just a shoe. This is the scan mesh, which looks amazing. And here, everybody who downloads QUICKSURFACE always tries the automatic surfacing. This is the ultimate benchmark. Nobody has any time to do any work. They just load something and then they just press auto surface. Auto surface is very simple algorithm. You can just use kind of a target how many, what kind of resolution you want to achieve, because it works with the quads. And then you provide what if there is a high feature details or not so much. And at the end, you have a symmetry option. And that's all that you need to do with this automatic surfacing. You just press a button and you wait a couple of seconds until the software analyzes the underlying surface and you get your solid in QUICKSURFACE. What you see here is the navigation panel where you can just use the history-based parametric modeling, and you can see the number of solids and surfaces. In this case, this is a solid. The good thing about our freeform surfacing is that it's fully editable, so you can always open and just modify the position if it's needed. At any point, you can just check the deviation, so you can analyze how accurate your work is, which you can see later. And at the end, for example, you can export as a step on IGS file format, or you can just press a button and the software can transfer all your work directly into Inventor. And at the end, you have this as a surfaces, the native surfaces in Inventor, as well as the parametric tree. Let's go back to QUICKSURFACE now, and I will just load another object so you can see again about the power of automatic surfacing. We just started with this shape, and then with the automatic surfacing, I just generate this model, which is great when you have nice and good organic shapes. This algorithm works very, very well. Now, the problem is that when you bring something which is a little bit more different, like a part like this one, in the reality, when you scan data, you will get shapes like the one you see on the screen. For one or another reason, you may not be able to capture any information inside the holes. You may get not a highest resolution. Probably the part here might be deformed, and there are other different problems that you may encounter on the actual imported part. Let's try to do automatic surfacing, and then we'll see what's going to happen. Now I say, okay, I need to get the highest details here, and then I press OK. How our automatic surfacing works is actually follows the curvature on the shape, and then this is how it generates the mesh. Okay, that's something we didn't get here. I will just try again with the highest resolution, and we'll see what's going to happen. As you can see, it actually fails here on this part because it cannot define what this is. The problem is that this part is actually very complex, and it cannot be recreated in the automatic surface way. For this reason, in these cases, you need to use the approaches which are more in the prismatic way. You need to extract the cylinders, you need to extract different shapes in and reconstruct with the standard CAD operations. But still, with this freeform surfacing, it's quite powerful because we may create a complex shape. I'm going to recreate this wheel very quickly here for you to demonstrate what we understand as a hybrid modeling. What I need to do here, for example, is I need to create a profile. Let me just create a 2D sketch. In our software, the good thing is we have something which is called for evolved surface. For evolved surface means that I can just use the, instead of just driving the section plane up and down in a direction parallel to where I started, I can actually pick an axis, and then the slicing plane just goes and intersects the mesh. In this case, I'll just take this profile to define my primary shape, and will create my sketch here. What we can see here is a very complex profile that you cannot recreate with the lines or arcs. So for this reason, I want to reconstruct it with the splines. What we have here is what is called the fit primitives options, and I will be using our tool which is called the fit curve. The way it works, you just paint over here, and then it automatically will extract the B-spline for you. Or even more, I can just brush this complex shape here, and it will approximate. As you can see, it created it with 26 points, but you can always just reduce this depending on your expectations of the accuracy. And also, this is fully editable, as you'll see in a second. I will just brush the rest of this to recreate it as a spline. And here, probably, I can connect this with just with a single line. I'll just go back and improve my shape of the profile. I can always create a tangency here, so they connect in a smooth way. In this case, because I need to close the profile, I probably need to get to the revolved axis and make sure that this is perpendicular. Let me just check if I close the profile. Everything looks good. The good thing is in our software that we have something which is called tolerance. So you can always just check the deviation from the underlying profile with the scan data, and you make sure that everything is in tolerance the way you model it. Once I'm ready with this, I can just press OK. What I need to do here is I'll just pick this sketch and create my revolved surface. So in this way, I very quickly created my first profile. It's flipped. I can just need to flip it so you can understand better. And now I want to reconstruct these complex shapes of the opening here. What we have in our software is what is called the freeform modeling. The freeform modeling is based on the sub-D technology that you can just draw a sub-D model on top of the mesh. How this works, you just create your first rectangle here, and then with the simple moving operations, I can just turn the snap on. That this means that my points will always be on the mesh. What I mean with this is that this allows you very quickly and easily to reconstruct shapes that are directly onto the underlying scan data. I would like to say that today, as long as I am aware, QUICKSURFACE is the only software that provides this functionality. You can find this snapping to the mesh in other packages, perhaps. I'm not going to quote any other software, but all you can do is just project something that you can do at once. But with our software, it's so easy because you just drag your handles and they always automatically will snap onto the underlying mesh. Furthermore, at any point, you can just turn the automatic deviation, and you can see how close you are with your design intent. I will just try to close this, and so you can see the workflow. I'm not very precise, but with these tools, it allows you to very accurately to get as close as possible to the underlying mesh. Let me just close this. You can see it just say merge. What I need to do now for the purposes of the project, I need to extend this a little bit more. We have extend operations here like this one, and I can close. As I said, because this is a parametric modeler, I can just select this and use the pattern tools, so I can create a circular pattern. We just create a 16. This is not very accurate, but it just shows you the principle. And here is the hybrid way of modeling. We will use our trim operations here to just try to get rid of the excess that it's not needed. As you can see, I can just quickly click and remove the part of the shapes that are not something that it's needed for us. As you can see here, the software analyzes and tells me that these are multiple surfaces. What my goal is now, just by removing these excess surfaces, is to end up with something that is called a single surface. And at any point, the software analyzes my what I've created, and you can see now it notifies me that this is a single surface. I can press OK, and you can see that I created my first shape now. This is the shape that we created just in a couple of seconds. Of course, you can always just create a fillet here because this is already a shape that is compatible with any cut tools. And then you can export this as a step or IGES. So I hope you get an idea of what the manual way of this hybrid modeling is. In order to save some time, I just want to focus on the advanced algorithms, but you can always learn from tutorials. What I mean here is this is a tool where this is a purely prismatic shape, and I very quickly created just the main body with the extrusion and just some cuttings. But what happens in this case? Now, as I said, if you don't have time and the accuracy is not important, what you can do, actually, I can just take this cam, I just have two meshes duplicated, and then I can, using some tools, I can just try to select the inner area of the shape that I'm not so interested about how to reconstruct the actual circles, but just to get it as close as possible to the underlying scan data. Perhaps I may just need to do more selection here to make sure that everything is selected. We have a lot of tools to improve the selection. What my goal here is just to tell the software that only this area is really important for me for automatic surfacing. And let's see what the software will do. Now, when I go to automatic surfacing, I can just get the option which is called extract from the selected triangles only. We can just wait again for the software to complete. And you can see what we got. So I don't have time, I don't have a way to analyze how this works, and I just rely on the software to solve this for me. Again, the best thing is that this is fully editable, which means that I can go and edit my shape. Now, because of this, I can always just improve my design. I can just tweak my shapes here to improve the connections. And so what I mean is that automatic surfacing is not a static result, but you can improve it. What the next step should be in this project, I can use our extrapolate function, which means that if I just take something, it will just take the boundary and move it out of our extent. Why I did this, again, this is the simplest way to complete the project. I'll just select everything and we'll use our mutual trimming operations. Just cut off what is not needed, press OK, and I completed my job here. This was the other very simple example. And today I am going to stay focused on a little bit more complex shape that will use the same approach, but we'll combine the way of using both prismatic and automatic surfacing. So let's begin with converting this to a proper CAD model. The reason for using hybrid modeling here is because if I use again the auto surfacing, this will just wrap around, but this is not what I need. So I will start with a normal CAD approach. We'll use the cross section. Let me just put it on the top. And we'll use for revolved surface to be able just to create a single profile that will define my main body here. This is somewhere that I just decided to get my profile. We have a lot of tools that you may learn from our tutorials to use stacked sections and advanced tools to get it more accurately, but for the demonstration, this is good enough today. Let me create this profile and reconstruct my shape. I will go back again, if you remember, to our extraction tools. I will just draw here. Let me just turn off the tolerance mode so you can understand better. I just brush over and create a line using the extract primitives. Because I have some limitations, it automatically decides if this is a horizontal or vertical. And this is quite a complex transition here. I can probably create a line here and define this as a fillet. Maybe this is also a few lines here that I want to intersect. You can see how easy the software extracts the lines. And I will just stop here. What I want to do for this area, this is not an R, so I probably want to fit a curve here. I will just brush over and the software will approximate. This is quite wobbly. Perhaps I need it to be with 6 points to get a way smoother surface. And I would like to do the same here to get this shape. Let me just make one transition line here. Going back now, I need to connect everything. What we have in our software is something which is called automatic join. If you press this, the software will just try to connect all the lines. If I just hold Control and brush over, if we have two lines, it automatically will find the fillet for you. I would like to complete my profile. I can just connect the shapes here. Of course, because this is a spline, I can just always just do the tangency using the control points. I can change the curvature so I can get as close as possible to the desired result. You can see this is a classic approach. Again, with the control, this will be defined as a fillet. And let me just finish this profile here, and perhaps I'll just leave it as it is on this shape. Holding the control will intersect. What I'm trying to do is just close this revolved surface. Because this is my define of the revolved surface, I will just draw a line somewhere here on top, and using the control key, we'll just close this shape. The reason I did this was to define my revolved shape here. Press OK. And one more step that I need to do is actually get a plane on top using the extract primitives. Click here and define a plane. We'll be using what we have as a mutual trim command. Taking the two, we'll just intersect. So now I created the main shape, which is fully prismatic. But what to do with the rest? This is so complex shape that I don't have time to implement, or may take a lot of efforts for me to do this. Let me just save this on the disk so I don't lose it for future reference. Actually, I need to complete this box here. The way I do it, I will just create a normal sketch, which intersects somewhere here. We'll create this sketch. What I need to do is, let me just hide the body. Using Control and Shift, we'll just extract these lines. Now I can fit a line, a circle here, but to be accurate enough, I just draw it manually so I can just get the best result. And we'll draw a little bit a line inside, going to intersect. And my goal is just to create this shape here that it's needed for a body. Using the mutual trim, which you are familiar from other packages, I just created my profile. Let me bring back the shape. We'll create an extrude. The extrusion has two handles which you can move up and down, and this one goes inside probably. What we have interesting in our software is the ability to snap to the underlying mesh. Snapping works, you just pick this handle and you move it. As you can see, it always picks a point from the mesh. It's very useful because I can just pick a point and the software in real time shows me the deviation and how good approximates the underlying shape. For me, this is good enough. I don't need so high accuracy. And in this case, I probably need to move this a little bit like this one. The main goal is so we can get a good conditions for the Boolean operations. What I mean with this, I can just select this body and this one, and then I can use the command which is called combine solids. Now we have one single solid body. Let's go back to our mesh. I'll hide the body for now, and my goal is to stay focused on the human shape here that I need to reconstruct. Let me just hide this, duplicate actually this mesh. The reason for duplication is just I keep this as a backup. I'm going to edit this. What I'm going to do now is just with the selection tools, just remove a lot of information that it's not needed. You may leave it as it is, but for the demonstration, I just want to make sure that the algorithms work a little bit faster. Otherwise, you may need to wait a longer time until the process completes. I just delete what is unnecessary. I ended up with this. Now, what I'm going to do is we'll use our tool, which is called split mesh with another cut model. And I'm going to show you what I mean with this. If you remember, we created the big solid, and what we have here is called a function which is called envelope. I just pre-select my active shape, which is in blue. How the envelope works is that it creates an envelope around it and deletes everything from the mesh. And it has a parameter, 2.5 millimeters. The reason for this is that this transition may have a fillet here, and I want to get rid of everything. Let me just press a button and so you can see what I mean with this. At the moment, this is an extensive operation, but you see that the algorithm just threw away everything which is 2.5 millimeters from the surface. You can put this to 0, but then it will capture all these small fillets that we had already. So in this case, I just start getting closer to what I need. And you can see here a lot of bodies. And I want just to stay on these two. I'm going to use something which is called individual meshes. The individual meshes approach allows you to remove everything that is not needed. And I'm just picking the main bodies and delete. Probably this one needs to go away. But what we have as an interesting feature is that I can just measure carefully and say, okay, remove everything which is quite small, but leave the main bodies because I'm going to need them later. As you can see now, I have 3 individual meshes. I can just always track and understand what it is. In this case, for the demonstration, I'm not going to focus. I'll just stay on these main 2 shapes. Now, what I have is a good suitable shape for automatic surfacing. We can easily just run our feature-based automatic surfacing and see what it does. As I said, automatic surfacing might be sensitive to the boundaries. That's why with this approach, we managed to actually help the algorithm to create a nice and good shape here. So this is my shape, but I'm still a little bit far from completing my object, my project. As you can see, if you remember, we created this 2.5 millimeters apart. How we can resolve this? What we have is some features in our tools to exactly for this workflow. Let me go and edit this freeform. I can just double click to select this boundary. And what we have as a function, it says offset boundary to the surface. How this works, it will actually take this boundary, analyzes, get it as close as possible to the other CAD model, and will project it. But even more, it will just add an extra distance of 0.5 millimeters. This is very good because this will help us later for the trimming process. So let me just pick this one, this big boundary, and apply the same operation here. I can just tell the software go inside. And also for this boundary here, tell the software to offset inside. We are nearly there. And in this case, I need to complete this join procedure just by taking this boundary and tell the software, okay, all I need to do is just go inside to the shape. And as you can see, it just moves all the points. Now, because what my goal here is not to see these white lines, I can just always just pick this something and just move it manually. The reason is for this trim operation that actually will do the job for me later, so I can just get a good result. Let me just put this inside the shape of the. I know this may sound complicated, but believe me, in many applications, this is the shortest way for you to achieve your goal. So what I did now, I'm nearly ready to move on. I just close. And one last operation that I need to do is what we call the trim operation. How it was working, I just select everything and say trim. Now the software will take the two and intersect. This might be quite a time-consuming operation depending on your computer, but it went not too bad. I just want to see the shapes here. You can see the excess that I need to remove here. And also I'm trying to cut everything that it's not needed because it was intersected with the other big body. Let me see the other shape. Definitely I need to create openings here where they join. And the same for this shape. I think this is already done. Because it's a big operation in the background, it was working, but you see it just tells me now it's a solid body. So I can just press OK. And the software will join the two shapes together and will create one final body. While we wait here, I can just show you that I created this and exported in Rhino as a full solid shape. As you can see, it's a single body. You can just see that this is a solid that you can export as a step or IGS file format for other use. Thanks to this approach, you can do quite a good, interesting elements like this one. I'm not going in details, but just for you to see what type of shapes you can generate, which otherwise you will not be able to create with any other approach. This has been delivered to us by our partner Better 3D in Australia, starting from the shape like this one. You can imagine this is a casting, and we have quite a lot of important surfaces here that they actually will be used in the assembly, but the rest is a casting, and it's not so important. And with this approach, you can achieve the results like this one. And otherwise, I don't know how you would actually do with any other approaches. Another example that I want to show, I hope it will open soon. Okay, it's just the memory. But as I said, you can see this as a step or IGES file format here. Okay. This is a seed, again, created with a similar approach. You start from the shape like this one, which otherwise you will not be able to do any traditional approach to reconstruct. And then you can just end up with this one. So this technology is using, again, the freeform surfacing, which they follow the shapes, and it was used exactly the same approach as you saw today. Now I'm going to switch back to my presentation. A few more words to say. What are the benefits for you? You can use our software as a great fit to your scanner. As long as your scanner can output the STL mesh, then you can pass it to QUICKSURFACE and generate the CAD model. It's a simple software. It's very easy to learn. And we pay a lot of attention on our training and how we educate the end user. We have more than 130 online video tutorials. When you open a function, there is a help button which actually takes you directly to a video where we explain how the software works. Also, when you install the software, it comes with example files that we use in our demonstration videos. So if you just follow my instructions, because I'm in these videos, you will just learn the basic and the advanced steps of QUICKSURFACE just by using exactly the same scan data that you see in the videos. We have an extensive worldwide resellers network, so if you would like to purchase our software, you can reach our local representative. We're doing our best, and they're very highly trained, so they can answer your questions. We have a big presence also in the social media, so whenever you see us, just follow us or subscribe to our channels, give us a like. And I would like to say we pay attention also on our responsiveness. And finally, we don't hide our prices, or we just don't limit you of trying our software. So if you just go to quicksurface.com, you'll be able to get your free 30 days trial. What our goal is just to make sure that the software actually fits your needs. We don't want to offer you software that you cannot use it in your application. So that's why just download, try it, learn it, see how it works for your applications, and then if you want to decide, you can proceed further with the purchase, or just reach to us and we'll be able to help. So honestly, that was my quick presentations. I can speak even more, but I hope you get the idea what the capabilities are of the new QUICKSURFACE 2024. So now I'll just go back to Barbara and let's get questions.
Thank you, Costa. What a great workflow overview. We have a question. Does Mesh to Surface have all of the same features as QUICKSURFACE?
Mesh to Surface doesn't have the advanced auto surface. There are two algorithms. One is called the basic auto surface, which is not as good as the feature align that you see today, but it's still good enough for a lot of applications, so you can still use it. The QUICKSURFACE allows you to work with multiple scan data. So what I mean is we have a lot of tools for mesh editing and hole filling. This is not a good example, but you have a lot of mesh processing. You can bring multiple scans together and so on. And then these functionality for mesh editing do not exist in Mesh to Surface. But it's a great, powerful plugins for if you are dedicated users of Rhino or SolidWorks.
Thank you. What if two people want to share the same key at a company? Is that a
Yes,
possibility?
we offer flexibility in our licensing. The software can be installed, what is called a floating license. We support two types. One is over the internet, which is known as cloud license. So people can travel and use this, or a lot of people have a confidentiality and restrictions by their IT departments. We also offer into the local network.
Okay, thank you. Now we have two connected questions. One says, what is the cost once you buy a 2024 version and a new version comes out? And also the other question is this a perpetual license? And now I keep my license updated, which is part of the same answer. I think there is a maintenance, right?
Look, let me explain. If you buy a software today, which is called 2024, this is a perpetual license. You can use it forever. When you purchase it today, it comes with 1 year maintenance already included. This means, what is today? Today is 24th of January. This means that until 24th of January 2025, you will be able to receive all the new versions. This means that if when we release the next version in November or December, you'll be able to take this one. Well, after that, if you don't pay a maintenance, you can keep working on this version forever. We'll support you with the transfer of the license and so on. But at some point, if you decide to come back, you need to pay all the maintenance or maximum 35% of the end user price. Our maintenance cost is 15%. So this means if you miss 1 year, you pay 15%. If you miss 2 years, you pay 30%. But after that, even if you miss 10 years, we have a limit that you only pay 35% to get back.
That's fair. And one more question. What if somebody doesn't pay for the maintenance and loses their laptop? Can they recover their key, their original license?
Because the way we work, including with Novage, that's why all our resellers must send us the information about the end user. So we have our database with all the users. We send out the certificate, which you can keep it in your email. And then in the future, you can just send us this certificate, which is a proof that you are an owner. And then we just reset our database. And we have a lot of cases. People just, their PC is blown, and then they just contact us and we reset the license and it works. But please keep the certificate. This is your proof of purchase.
Yes. And we usually do a good job at retrieving it if somehow that gets lost too. So that's one of the perks of buying through a reseller. Like Novage.
To help people, not to just,
Yeah. So thank you so much, Costa. I'm going to take the screen back. If you think of other questions, we have a couple of minutes left just to show you where we can get QUICKSURFACE at Novage. Just go to novage.com and search for the product, and boom, you can add to cart. You can call us anytime and talk to one of our experts. Novage is, offering so many solutions, so you can do all your software and CAD shopping at Novage. Thanks again for this awesome demo of the great new functions of QUICKSURFACE. And hope to get another presentation within this year, Costa. And have a great day, everybody. And thanks again.
Thank you, everyone. Thank you.
Bye-bye.